are the angles in the same position relative to each other. So these are corresponding. These are corresponding. These are corresponding. And these are corresponding. Okay, so we have what's called a corresponding angles postulate. Now, just for some background information, do you see these triangles here? That triangle and that triangle? When you see that mark on your on lines, they indicate parallel. Triangles. And it's plural, not possessive, so whatever. Okay, so when you see these two triangles, that means that these two lines are parallel. So if this was line A and this is line B, that means that line A is parallel to line B. Okay. So that's how you know for sure that two lines are parallel just looking at a picture. Even if, sometimes they may look parallel, but that doesn't mean they are. If they have those triangles, that means they're for sure 100% parallel. Okay. So what the corresponding angle postulate tells us.
You said all three?
No, A. This means parallel. The double line. Yeah, the double line here is the symbol for parallel. I could see how you might think that said all B though. Okay. So what we have is angle 1 is congruent to angle 5 because those are in the same position, they're corresponding. Use a different green because that one won't show up. Angle 2 is congruent to angle 6. Angle 4 is congruent to angle 8. And then I'm just going to switch to orange because yellow won't show up. And angle 3 is congruent to angle 7. Okay. And if you think about it, parallel lines have the same slope, right? So that means that they're going in the same direction, and we measure an angle based on the space in between the two lines. And so if we're measuring, let's say, angle 1, our transversal is the same across because it's a straight line. And then if these two lines are going in the same sort of slope, right, then they would be the same distance away to measure the angle. Does that make sense? Well,
wait.
Yeah, so since this line is straight, it's transversal, it's flat, and these lines are in the same slope, that means they're moving the same direction, like the polar tracks, they're parallel. So that means the distance for the angle measure from here to here is going to be the same as from here to here, and that's the same for all of the parts. So that's why we know that the corresponding angles will have the same measure because the slopes of the parallel lines are the same.
So like if it gives you a degree to one angle, you subtract that from 180 and you get the other?
Right. So well, let's say I know that angle 1 is 40 degrees, then I know that angle 5 is also 40 degrees. And then if angle 1 is 40 degrees, angle 3 is 40 degrees because of vertical angles, right?
Wait.
Vertical.
Vertical, they're cross.
So these would both be 40. And since I know this is 40, that makes this 40, and these are both 40. And then I could find out, by subtracting from 180, I could find out what 2 is, and that tells me what 6 is, and vice versa. You see what I mean?
You said if angle 1 was 40?
Yeah, if it's 40.
If it would to say it was 40, right?
Yeah, I'm just hypothetical.
Okay.
So if angle 1 was 40, that would make angle 2 140, because we'd subtract from 180.
Okay.
Because it makes a straight line. And so since angle 1 and angle 5 are the same, and angle 2 and angle 6 are the same, if these are 40 and 140, I know that these are also 40 and 140.
And then
we define all of the angles from.
You just take, okay.
Does that make sense?
Yeah.
Okay. So the corresponding angles tell us that those are congruent. Any other questions on that? in the figure, if the measure of angle 5 is 72, so we're here. We have postulates or theorems to find the angles of, or the measures of angle 4. So first thing I always do, this is just me, I go through and I say those are the same, those are the same, these are the same, and these are the same. Okay. Well, if angle 5 is 72, I can find angle 6, can't I? I can do 180 minus 72, and that gives me 108. Well, if angle 6 is 108, what's angle 4? 108. So the postulates or theorems I used was a linear pair and corresponding angles. Right? I used linear pair to find the angle 6, and the fact that 6 and 4 were corresponding gave me 4. Okay. If angle 4 is 108, what's angle 2? Well, I can find that in a couple ways. I can either subtract from 180 and find angle 2, or I can use the fact that 5 and 7 are congruent from vertical angles, and 2 and 7 are congruent from corresponding angles. So there's 2 ways to get to it.
So from 5 to 1, everything on that side is 72?
No, but I'll show you something in just a little bit when we get further into it. So I could use vertical angles. That told me 5 and 7 were the same, vertical angles. And then corresponding angles told me that 2 and 7 were the same. So 5 and 7 are the same from vertical, and 2 and 7 are the same because they're corresponding. Does that make sense at all? All right, so we're going to use the same picture, but we've got different angles now. Okay, or different numbers. So I'm going to come in and I'm going to erase these numbers. And we still have the same corresponding angles though. 1 and 8 are the same, 2 and 8 are the same, 3 and 5 are the same, and 4 and 6 are the same because of corresponding. So if 8 is 105, okay, that's what I've been told, it's 105. Angle 1 is corresponding, so it's also 105.
Oh, 105.
Yeah. So angle 1 is also 105. Angle 2, well, we can say that if angle 1 is 105, angle 2 is 180 minus 105, and that makes it 75, right? Because these two make the straight line, and the straight line is always 180. So 75. And if angle 2 is 75, what's angle 3? They're vertical. 75. Help? A little bit better?
Yeah.
Examples lead us, so the corresponding angle postulate and taking us through these kind of examples, they lead us to some theories, some actual theorems, which is that, let me write them first. Okay, so we have 3 theorems. We have alternate interior angles, alternate exterior angles, and consecutive interior. Okay. What we were able to figure out based on the corresponding angles, vertical angles, and linear pairs, those postulates and things we were just using, is that if you have 2 parallel lines, again these arrows indicate the parallel, alternate interior angles, so 3 and 6 are congruent, and 4 and 5 are congruent. Okay, and then we have consecutive interior Interior doesn't have that extra n in there. Okay, consecutive interior angles. So that's the 2 on the same side. So 3 and 5 add up to 180. 4 and 6 add up to 180. And then you have alternate exterior angles are congruent. So 2 and 7 are congruent, and 1 and 8 are congruent. And here's how that all works out. I'm just going to go through this. So let's say I know angle 1. Well, if I know angle 1, I know angle 4 because of vertical angles. Well, if I know angle 1, I also know angle 5 because of corresponding angles. And that made 4 and 5 congruent. But if I know angle 5, I know angle 8 because of vertical angles. And that made 1 and 8 congruent. Now, if I know angle 1, I can find angle 3 because I can subtract from 180. Well, if I know angle 3, I know angle 2 because of vertical angles. And then 3 and 7 are corresponding, and 6 and 7 are vertical. So what I end up with is 4 angles that have one measure and 4 angles that have another. So all of the red angles will be congruent, all of the green angles will be congruent. And then you get this really nice situation where every red adds up to a green to make 180. And it's like a checkerboard. See, red, green, green, red, red, green, green, red. So if you have those parallel lines, you get a checkerboard of matching angles. Use all that. So we have Reading Lane and Creek Road, and they're parallel, and they intersect at Park Road. Or they don't intersect, they intersect Park Road. So Park Road is our transversal. Okay. And Creek Road and Reading Lane are parallel, so I'm going to go ahead and put like little triangles on them so I remind myself that they're parallel. Okay, if the measure of angle 1 is 118, I need to find the measure of angle 2. Well, I know that angle 3 is going to end up being the same as angle 4. And angle 1 and angle 2 are going to be the same.
Since vertical angles or whatever with the other green circle that you have blank, the top, that would be 118, right?
Mm-hmm.
And then couldn't you just say the whatever, like those 4 have to add up to 360, right? For a circle. Could you do it like that?
You could. It's easier just to say 180 and just subtract from 180. So you're right that all the green ones are going to be 118. So angle 2 is going to be 118. Angle 3, if I needed to find it, if I was trying to find measure of angle 3 on this particular drawing, I would do 180 minus 118.
Okay.
And then, so that's 180 minus 110 is 70 minus 8, so 62. And then I would know from this particular time that all the red ones are going to be 62. If I was trying to find those. We're going to use the same drawing. So let me just come back in, and these will all be the same. And then these will all be the same. Okay. So I'm going to use the same drawing. If angle 1 is 100, I want to find angle 4. It's going to be 80, because it's going to be 100 minus 80, because one's red and one's blue, and they'll add up to 180. And then if angle 3 is 70, angle 4 is also going to be 70, because they're the same. So I should put an if here. So if that, then this. Our key concept is all of these angles match. And all of these angles match. And if I take the two angles and I put one of each color together, I'm going to get 180 degrees. So the example that they gave you, the lines were not indicated as parallel, and so the angles should not have matched. So here we have, these lines are parallel, these two aren't. So when that happens, I'll get this pretty pattern here for the parallel lines here. And then I'll get another pattern over here where the two patterns aren't going to match. And the reason they're not going to match is because this angle is not going to be the same as that angle because these two lines aren't on the same slope because they're not parallel. Now if both lines are parallel, both sets of lines rather, so you have four lines with 2 and 2, then you get a situation where you have the checkerboard repeat throughout. And then we'll do purple. Okay, so the fact that they're both parallel gives you that repeating pattern all the way throughout. If they're not both parallel, you get two different sets. Have algebra, yay! All right, angle 4 is 2x minus 17 and angle 1 is 85. So like I said, the very first thing I always do is I just go through and I mark them and I say, okay, all those are the same, all these are the same. I have angle 4 and angle 1. Angle 1 is blue, angle 4 is red. What do I know about a blue and a red? They don't match, but they do equal 180, correct? So angle 4 plus angle 1 is going to give me 180. So 2x minus 17 plus 85 is equal 180. 85 minus 17 is some number. 68. So I'm going to add 68 to both sides. And I'm going to get 2x is equal to 248.
How come you said them equal to each other? The 2x minus 17 plus 18. How come you said them equal to each other? I mean, how come you didn't say them equal?
Because 1 is blue and 4 is red. Do you see that? So here's 1. 1, 3, 7, and 5 are the same, and then 2, 8, 4, and 6 are the same. So 1 and 4 aren't equal, but they do add up to 180. So then once I've got that, I get x is equal to 124. Now with these kind of problems, it's always going to be the same. It's going to be either they're equal or they add up to 180. Those are your only two options. If the colors match, they're equal. If they don't match, they add up to 180. So I have 3 and 7. 3 and 7 are both blue. So they're both blue.
Wait, for the first one, aren't you supposed to do minus 68 to see what it's...
Yes, I was. Thank you very much. Apparently I can't do math this morning. Good catch. Minus 68, not plus 68. So it's 112, not 200 and whatever I said. Uh, 56. Thank you, John. Okay. Let's see if I can add and subtract on this one. 3 and 7 are both blue, so they're equal. So I'm going to set them equal to each other. So 7y plus 6 is equal to 4y plus 30. I'm going to subtract 4y from both sides. and I'm going to get 3y plus 6 is equal to 30. And then I'm going to subtract 6 from both sides. And I'm going to get 3y is equal to 24. And I'm going to divide by 3 to find out that y is 8. Like I said, I just go through, oops. And you don't even have to, you could do this like this if you don't want to use color. I can just go through and circle, and the circled ones are equal, and the not circled ones are equal to each other, So,
Box out the other ones and do squares.
yeah, or I could do squares. Oh, I don't want to do those kind of squares though, because then I might think I'm doing right angles. So I could do a star, right? So circle plus star equals 180. And all the stars are equal and all the circles are equal. So I have a typo. The measure of angle 2 equals 4x plus 7 and the measure of angle 2 equals 4x plus 7. Well, of course it does. Oops, minus 13. Oops. Okay, so 2 is 4x plus 7 and 7 is 5x minus 13. Well, what do I know about 2 and 7? They're both equal, so I can do 4x plus 7 is equal to 5x minus 13. I'm going to subtract 4x from both sides because I like to keep my x's positive. You don't have to. So 7 is equal to x minus 13. If I add 13 to both sides, I get 20 is equal to x. Okay. 5 is circled and 3 is starred, and so I know that they're not equal to each other, but I know that they add up to 180. So 3y minus 2 plus 68 is equal to 180, because 3 and 5 add up to that. So that's 3y plus 66 is equal to 180. Subtract 66 from both sides. And I get 3y is equal to 114. Divide by 3. And y is equal to 38. Okay, so we're in a plane. All the lines are coplanar. So if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay, and it kind of makes sense because if you think about it, we're parallel. Sorry, I didn't mark those. Those are parallel. And if this is 90, then that makes this 90. And this is 90, and that is 90. So they're all 90. So everything's perpendicular.